Hello, Father.
Hello, Madre.
Bueno, y yo hice una pregunta hace media hora y usted todavía no me contesta.
You know, I try to help kids. I try to help, and this is a thanks I get. Okay, go ahead.
¿Cuál es la influencia de Newton en la ciencia y en el pensamiento de su época?
Okay, in order to answer that question, I need to talk about what Newton does. Okay, that's radically different. Okay, so I've argued that it's a liberal art. Okay, because there's a making and a modeling thing, and also shedding light on things worth knowing for their own sake. In this case, as we see in a little picture over here, I don't know how to. In this case, both the things away from the Earth, sun, stars, etc., and things motion within the Earth. Okay. So let's talk a little bit about what Newton does. That's kind of cool. He has three important laws. The first one is, when you set something in motion, it will remain in motion until something hinders it. And we can talk about that in a little bit. Second one is the formula for force. It's mass times acceleration. However fast something is moving, how accelerating, and its mass, that gives you the amount of force. And then finally, that for every action, there's an equal and opposite reaction. So if these things act on each other, they're going to react from each other like that. Okay, so those three things. And with those laws, he explains, for example, why a body is rotating, like say the moon, to make it easy, why the moon would be going around the Earth. If that's true, I mean, Ptolemy thought it was a heavenly body, and that's why it goes in perfect circular motion. It's something heavenly, something perfect. And Newton says, no, there's another way of looking at it. Again, a model. This thing was set in motion, and it's going to remain in that straight line motion until something hinders it, let's say this moon. But here you have this mass, and here you have this other mass, and this one's a lot bigger than this one. And so this, as this thing's moving quickly, now mass is attracted to each other. That's an important point in Newton, that mass is attracted to each other. And they're attracted to each other according to the distance. So the force of the attraction is, according to him, according to inverse square law of the distance. So whatever the distance is, it would be 1 over that distance squared. That would be the force of the attraction that these two things have on each other according to their mass. And so as this thing is moving, and this thing might be moving too, there's this attraction, and it keeps wanting to go forward, but it keeps getting attracted to each other, keeps wanting to go forward, until a kind of a calculus thing happens, that the straight becomes the curved. And because of this constant thing set in motion, remaining in motion until something hinders it, an equal and opposite reaction of this attraction towards each other, you end up getting this moon moving around per accidens, moving not per se. Per se motion is straight, but because they're reacting with each other, it ends up being rounded like that. So that's pretty cool. But why do I mention that? Because he applies those things, say, with other things like light, like magnetism, like motion of water, sound, motion of sound. And so he explains, he comes up with mathematical laws of nature, okay? And so let's look to kind of explain. I'm going to set up this kind of tension between his first law and, say, the way we experience reality, okay? So he would say he says, something remains in motion. If a thing is set in motion, it will remain in that motion until something hinders it. And so, like, if you see a trucha, a trout, a fish, swimming in muddy water, if it could, it would be swimming like this and be very difficult. But if you get rid of all the mud and you make it pure water, the fish goes, and it swims a lot faster because there's less resistance on it, and it takes less force to move at the same speed, say. Now that's all cool, but then you say, what if it had even less resistance on it? What if you take away the water and now it doesn't have any resistance from water and it's only air? Well, you wouldn't have that kind of motion. You wouldn't have swimming. Okay, you would have flying, and let's say the fish could fly, all right? We'll say the fish could fly. Now there's resistance from air, okay? But you know from flying yourself or being in a jet, that the jet needs that air, the plane needs that air in order to stay suspended. It needs force, and it needs to move through that force. But if it doesn't have the air, the plane can't fly, okay? Now, this kind of stuff, these rules apply, more strictly speaking, say, in stuff from outer space, because it seems like there's not much resistance up there. And again, I don't pretend to know about astrophysics or anything like that, but you can imagine that there's not so much resistance. So it seems like his laws would apply most purely in the astronomical stuff and less purely in natural stuff. Okay? So that, first of all, I kind of explained how Newton is doing astronomy, but he's doing more than astronomy. He's doing, with his laws, he's talking about the mathematical principles of natural philosophy, of motion. And that's what natural philosophy is about. Physics is about motion. Heraclitus, Thales, guy who lived 1,000 years before Aristotle, I think. How is it that this thing becomes that thing? Oh, because Thales said everything is water, and there's a different amount of water, and because it's not a dumb thing to say. But look, all those guys,
Presocráticos.
yeah, all the pre-Socratics and Aristotle, they were concerned about motion. How is it that things change? Not just local motion, but how a cockroach becomes dust. How did that happen? Okay, and Newton tries to explain something of motion. First of all, local motion. And he does so with these very cool laws. And they shed light, really, on the way things work in nature. But they don't explain everything. It's just like geometry doesn't explain about a beautiful woman's face. There's more to be explained there. Geometry can talk about proportion, but it can't talk about brilliance. It can't talk about integrity or something like that. That's part of that beauty. And it can't talk about love and relationship. But it's very cool. It's, as we know, geometry is a science about things made by reason in imagined continuous quantity. So it's about figures. And reason can come to see things about those, and it's very cool. But it's not everything. Likewise with mathematical physics. It sheds light on things worth knowing for their own sake, but it doesn't shed light on everything. It looks at a mathematical way. Now, Madre, I'm ready to answer your question on whether there's this break. Okay, we'll do that in a little bit.
Thank you, Father.
Okay.
Cool.